Okay, here's problem number 6. Suppose that you could spend $6 every minute, night and day. How much could you spend in 8 years? And we're assuming that there are 365 days in a year. Okay, so here I'm going to use a calculator for this one because now she's going to spend $6 every minute. So $6 for every minute, and 60 minutes in an hour, so that's 60 times 6, or $360 in an hour. And there are 24 hours in a day. So if we do 360 times 24, you get $8,640 in a day. And there are 365 days in a year, so multiply that by 365, and you have $3,156,600 in a year. Multiply that by 8 years, and you'll get $25,228,800. So here she can spend, this person can spend $25,228,800 in in 8 years. If this person will spend $6 every minute, night and day. Alright, next problem. The perimeter of a rectangle is 500 feet. The length of the park is 40 feet longer than the width. And you want to find the length of the park. Okay, now we can do this algebraically, where you're going to let x be the width of the park, and then x plus 40 be the length, because it says that the length of the park is 40 feet longer than the width. And then, of course, it is a rectangular park, so the perimeter is 2 times the length plus 2 times the width. So here, the perimeter is 500. That's 2 times the length, which is x plus 40, and 2 times the width, which is 2 times x. And then we solve this equation. 500 is equal to 2x plus 80 plus 2x. And then add 2x and 2x, you're going to get 4x, so it'll be 4x plus 80 is equal to 500. Then you'll have to subtract 80 on both sides to get 4x equals to 420, and divide by 4 to get x is equal to, let's see, 105. So we know that the width, because we're letting x be the width, that's 105. Now to find out what the length is, that's represented by x plus 40, which is 105 plus 40, or 145. So here, the length of that park is 145 feet. Okay, and then the last problem is this. Consider this mathematical machine, which is this machine on the right-hand side. And it asks, what number would you have to use as an input if you want 37 as the output? Okay. Now here the output is going to be 37. So if we want the output to be 37, that means we're going to work backwards here, or do the opposite of each one of these commands that we have here. The output would be 37. To get that 37, we had to divide some number by 2. So now if we multiply 37 times 2, you'll get 74. And then we subtract 10 to get to 74, so that means we need to add 10 to the 74 to get 84. Now we multiply by 6 to get the 84. So the opposite of that will be dividing by 6 to get, I think, 14. And then we added 4 to get the 14. So we have to subtract 4 to get 10. So our input will have to be 10. Okay, so if we want the output to be 37, the input will have to be 10. And then for part B, what would you have to input to obtain an output of 49? And we'll do this the same way as we did that other problem. We'll start off with the 49. We divided by 2 to get 49, so we had to multiply by 2. So it was 98. We subtracted 10 to get 98, so that means we had to add 10 to get 108. And then multiply by 6. That means we have to divide by 6 to get, I think, 18. And then we added 4 to get the 18, so we have to subtract 4 to get 14. So the input had to be 14 for us to obtain an output of 49. Okay. Now these are just some of the problems that you'll see on the MyMathLab homework, and this should help you do some of those problems.